Okay, so today I am going to discuss another PYQ from TIFR 2022. So the problem states like this: an observer O moving with a relativistic speed v away from a fixed plane mirror M. So here is a plane mirror M, and the observer O moving with velocity v and moving away from it. So here is the mirror and it is moving in this direction v, uh, and send a pulse of light of wavelength lambda towards the mirror. So it will send a pulse of wavelength lambda towards the mirror. Okay. So you can think like there is a torch, and the torch is moving in this direction, but it is sending pulse in this direction. Okay, this kind of thing. So the wavelength of the light reflected back to the observer will be, so the pulse will hit the mirror, then it will reflected back, then it will again reflected back with some changed frequency. So here it is lambda, then here it will be lambda prime. Okay, something else. So the what will be the received frequency by the observer. So please pause the video and give this problem a try by your own, and then look at the solution. Okay. So for the relativistic Doppler effect, some things you should keep in mind, and these are very useful to write the formulas actually. When you are an observer, so you are an observer O sitting at Earth, and some some star or anything, something source is moving away from you with some velocity v, so it is moving away from you. So you get Doppler shifts. This thing you know, but the thing you get confused that it will be red shifted or blue shifted. Okay, so when the object is moving away from you, then it will be rate shifted. Okay, if it is moving away, it is moving away, then it will be rate shifted. So wavelength gets increased. Okay, and if it is moving towards you, if it is moving towards you, then it will be blue shifted. Okay, its wavelength get reduced. So this phenomena you should know actually, because then you can easily write those formulas. Okay, and for, let's see now our case. So first thing that it it is like an observer. The mirror itself behave like an observer. So it is an observer. Some source is moving away from it. Okay, so what is the received frequency by the observer? So it is emitting lambda, but because of its relativistic speed, say it is lambda double, so it will receive some lambda prime. So it is emitting lambda, but the observer will see some lambda prime because it is moving with relativistic speed and moving away from it. Okay, so lambda prime will get red shifted, so its frequency will increase. Okay, so 1 plus v by c divided by 1 minus v by c, so it is get increased. Now your actor getting reflected, so now this will behave like a source, and this moving observer, it is moving, it is a observer, but now it is moving away from this source. So the source is emitting some lambda prime, the source is emitting some lambda prime towards the observer, and the observer is moving away, observer is moving away. So only relative velocity matters for this any kind of this kind of problem. Okay, so when this is moving away, so you can think the source is moving away and then the observer is stationary. So the received frequency by this moving observer will again get redshifted because it is moving away. Okay, so it is lambda prime into 1 plus v by c divided by 1 minus v by c. So your lambda prime is this. So it is finally 1 plus v by c divided by 1 minus v by c. So you can now simplify it. Okay. So this is, if you look at the solution, it is just a two-line solution and this is a simple problem. but you have to keep two things in mind. The first and very important, the most important thing is this, that if something source or observer whatever is moving away, then it is get red shifted, and it is moving towards, then it is get blue shifted. Okay, red shifted means wavelength will increase, and blue shifted means wavelength will decrease. This is the first thing. And the second thing, you have to keep these things also in mind, that you have done in, Doppler effect of sound in class 11 actually. So these things you should also keep in mind, that when some source is moving towards a reflector, then you should consider this reflector as an observer first, and after getting reflected you should consider this as a source. So first it will behave like an observer, then it will behave like a source. So before receiving the signal it is behaving like an observer, and after reflecting the signal it will behave like a source. So these two things also should keep in mind, and if you keep these things in mind, this problem is a two line problem. Okay, so yeah, that's it for today.